Machines as a complement to man. Flying machines. Drawing machines. Machines to fashion metal with hand and with spirit. A constant dialogue between man and machine. A dialogue expressed at all levels through computer language, a language where the image is now integrated. Such is the language spoken at Dassault, the language of CAD/CAM, computer-aided design and manufacturing. At Dassault, CAD/CAM, first and foremost, consists of men with their creative spirit, of computers with their processing memory capacity, of terminals, all of them just so many ears, eyes, and mouths for mutual understanding and common achievements. At Dassault, CAD/CAM has 75 design stations in 7 factories, 500 people dialoguing with the computer, a system fully integrated within the industrial process. A reality which foreshadows future methods of production from design in the engineering department to final quality control by way of tool definition and machining of parts from the simplest to the most complex. CAD/CAM, a gateway to the future, which in fact started 15 years ago and which now, for the workers of Dassault, men and women, has become a daily reality. Men and women fully confident in the system which is at the service of all, making for stepped-up productivity, efficiency, speed, precision, and dedication. A system which at all echelons gives them creativity for increased responsibilities. In order to better understand the integration of CAD/CAM within Dassault, here's an abridged account of how an aircraft component is produced, namely the main structure of a Mirage 2000. With the overall definition of the aircraft known in the computer, the selected cut defines the shape of the structure. The precise definition of the component takes place in the engineering department. For this type of operation, the graphic scope with its keyboard and light pen is at present being used more and more instead of the drawing table. This scope is but the window into the computer and its highly reliable memory. Just so many elements which enhance man's decision-making possibilities. Thus, the design engineer can devote himself entirely to the creation of the component which before his very eyes, after ceaseless refining operations and readjustments, assumes its final shape to reconcile often diverging constraints, for instance, aerodynamics, performance, structural strength, aesthetics, comfort, etc. Rapidity and optimization of design that no other system can equal. Thus, by successive stages, the component is developed in its minutest details in the engineering department. The technical characteristics of the component are stored in the main memory of the computer in the form of design parameters by the engineers themselves. Likewise, the engineering drawings of the aircraft are computer controlled and produced in just a few minutes. As the computers in the different sites are linked by a telephone network, processing and telecommunications are used to transmit the drawing to the production units. The drawing is thus instantaneously transmitted by the engineering department computer to the factory computer for manufacture of the part. The computerized image received in the factory can again be displayed immediately on site. The manufacturing engineer is in charge of developing the machining process of the component in the workshop computer. The data is then transmitted to the machine tool, which sculpts the shape designed in the engineering department in the metal. This explains the presence and integration of CAD/CAM at all production levels. CAD-CAM is a nervous system, the pattern of which can be seen from the very moment the drawing, prepared in the engineering department, is displayed on a design station in the factory. The manufacturing engineer modifies his drawing, preserving only the basic geometric shape of the component. Then he determines the shape of the cutting tool and its travel, indicating the successive surfaces of the component coming into contact with the tool. At this stage, CAD-CAM discloses its true role of production tool. For this particular part, several numerical control passes are necessary. First, a rough machine shape is executed on a 3-axis numerical machine tool. This programming process, with the actual motion of the proposed machining, is displayed on a scope. And the computer again pilots the numerical control machine tool, which gives the component its preliminary shape. The programmer then works out a finishing pass, which will be effected on a 5-axis machine tool, which can reproduce the highly elaborate outline of the part. At the end of the production line, the completed part is compared with the theoretical shape stored in the computer memory on a numerical control checking machine. When validated, the finished part is fitted on the plane. Most parts and tools required for the construction of the Mirage 2000 are designed and built in the same way as the structure just described, a story in which CAD-CAM had a hand throughout. With the new Catia computer language, a computer-aided three-dimensional interactive application, a higher degree of technology has been reached. This system and all-around development by Dassault definitely breaks away from the limitations of purely plain drawing. Catia, high-efficiency algorithms to determine and optimize complex shapes. In the case of a civilian aircraft horizontal stabilizer design, for instance, the design engineer develops the wing profile curve using the reference points obtained from aerodynamic calculations. Smoothness of the profile can be evaluated by visualization of the wing outline. Then the operator smooths out the curve with Catia, automatically optimizing its profile within given tolerances. Then the various profiles of the wing are positioned in space so that the design engineer can build the surface limited by these profiles. Just as for the wings, all the other components of the future plane are stored in the Catia database, a fully integrated system at Dassault, and are always available for use by the designer. The operator is now selecting the successive curves on which the wing surface rests, which is the upper face of the aircraft's vertical stabilizer. The next stage of the whole process is creating by symmetry the complete wing definition. It is examined from different angles. The front, the upper face, the side, and finally rotation in space around the trailing edge of the vertical stabilizer. Catia, an operational approach to shapes which considerably facilitates studies of theoretical aerodynamics. Catia, an operational approach to shapes defining machining of components, the shape of cutting tools, and necessary technological data. The operator describes tool travel by selecting the surfaces where it must come into contact with the metal. On the screen, the successive positions of the contact point of the tool on the metal are displayed to check programming of the tooling operation. Machining itself is performed on a numerical control machine tool of the type shown here, which gives the wing surface of the aircraft its general outline. The aircraft model is afterwards tested in a wind tunnel. Its shape is a faithful image of the original drawing. Catia optimizes the definition of complex components, as for instance the Mirage F1 refueling probe, a device with very specific conditions of use. Catia is the open door to all objects. This very complex fillet. This unusual pipe. This simple volume with a complicated plane section. This very sophisticated mechanism. This robot with optimized movements in space and time. Catia is also a designer. Witness this telephone. An automotive engineer with this complex enclosure. A general mechanic with this connecting rod. But Catia also aims at further objectives, like offshore drilling platforms. Catia, a medical research tool with this artificial heart. Catia, architect and interior designer, making its way right into this house, highlighting its habitability. Catia is the materialization, the emergent portion of Dassault's CAD/CAM integration, a time-saving technology reproducing the original technical concept with pinpoint fidelity at all stages of production. The precision of this system is second to none. A system which generates more competitive and higher performance products. A system which at Dassault's is already routine. A system catering to individual creativeness, individual responsibility, promoting man to a foremost place in the progression of industry. CAD-CAM, a combination of decision-making aids launching Dassault towards future achievements.